Okay, so with this one, it says the value of a van purchased for $45,000, so you know that's VO, is depreciated by K% per annum using the reducing balance method. So you'll know that you're in reducing balance method, and they've called K per annum. So we know in our formulas that's little r. So little r is what they're asking is for K. And it says after 3 years of this depreciation, in the 4th year, it changed and went to the unit cost method. So this is how they're going to change it up. You have a change of scenario. So it goes 3 years with reducing balance, then it goes to unit cost depreciation. And it's 15 cents. So just be careful. We change that to dollars because we know we're talking about dollars. And then it's told me the value of the van at 4 years was this. So you know V4, and they want you to go back and find what the interest rate was for the reducing balance. So when you have these, what I call these are like a change of scenario. That's what I say. It's a change of scenario happens. So what you want to do is you sort of plan out and show what happened. So I'm going to say, well, VO, I started with 45,000. Okay. And for 3 years, we had the reducing balance method. Yeah. We did the reducing balance method. So then it would have been V3. So it would have had its value at V3. And then what happened is it went down and we got to V4. But while in that 4th year, it used unit cost depreciation. Okay. And so what you know is, and then you know what V4 is. They told you what it finally gets to, and it gets to 26,166.24. So they told me that. So the value of the van, though, they did give me another piece of information. They said the value of the van after it travels 30,000 kilometers in the 4th year. So during this year, when it went from this value down to this value, it went for 30,000 Ks. Now at unit cost, so what you do is you try and charge it by the unit cost, which was 15 cents. So really that equals 4,500. So what happened was 4,500 was deducted from this amount and ends up being that amount. So how would we go back to that? Yeah, we'll add it. So just to show you, I'll just do it over here on the side. So what I've got, V4 was 26166.24. And I'm going to go, I know if I add that 4,500, that's going to give me the V3, which was missing. So V3, so if I add 4,500, I end up with this value. So now I know a V3, and I also know what VO was. So what you can do in here, within this part, there was, so it went back to that, but we had the reducing balance method. So what I can do, I know two values, so I'll pop in the nth term formula. So remember, the nth term formula for reducing balance is r to the power of n times VO. And we have a formula for r. So what I'm going to do, which I'll just pop that in there. So it's 1 minus the rate over 100 to the power of n times VO. So that little r is our question, but I have everything else because what I'm going to do is I'm going to use V3 in that formula. So I'm going to say, well, V3 equaled 30,666.24 equals, I'm going to do 1 minus r over 100. Now this is V3, so it's the power of 3 times VO is 45,000. So when we have one little unknown in an equation, what can we do? So I'll use solve, comma, R, and I'll end up with, I'll find out that R equals 12%. So that is quite a difficult question. So it's question 29, so it is very late in the financial multiple choice of your exam, so it's going to be difficult. So the way you have to do it is always plan it out. It makes it a lot more simpler to understand when I've done that, isn't it? So that's what you want to do. Sometimes you just have to go, what do I know? And you put it out on paper, and then you might be able to see what happens. All right, this next one is, now I just wanted to bring up, this was last year and really poorly done. Now it says a first order linear regression relation. So first order means they're going to add something else to the rule. So you can see like there's a linear part there, but there's a geometric, a timesing part there. So it generates a terms of a sequence. So this rule will create a sequence, but they want only a geometric sequence. So if they only want this rule to produce a geometric sequence we've seen should only be like that. So a geometric sequence only should have the timesing part. So, a geometric should only have a multiplying number, which we know is that big R. So if I want this rule to be just a number at R, what does D need to be? 0. So is there only one answer with that? Yeah, so that's D. So that was quite hard. Kids were not ready. So the thing you'd really need to know is when they say a geometric sequence, it is just timesing. If they say just a linear, you would just be adding. So when they add something else, like say they say first order, that means they're putting something, they've got, because there's a combination there. All right, so that one was poorly done. I just want to, because you'll get a repeat of that this year. They'll adjust it somehow and then you'll get it. Okay, and just this last question here. It says, invested 2,000 in for a 3-year at 4.4% per annum, compounding quarterly. So I'm adding all those little facts up there. So because they said compound, I know that's compound interest. Now it says to earn the same amount of interest in 3 years in a simple interest account, the annual simple interest rate would be closest to. So what you want to know is you want to know how much she got at the end of her 3 years with compound interest. And then you want that to be the same scenario if it was simple interest. So let's first of all find out what they actually would have got if they did, when they did the compound interest. So compound interest, now remember this is 3 years. So if it was compound interest and it's 3 years at quarterly, N will equal 12. So I'm going to say I really want V12, which would be, and I'm going to use, so the compound interest formula for the nth term, remember, is this. So I'm going to use 1 plus the rate, which is 4.4 over PPY, which was 4 over 100. So if you look up the formula, that's what it is. Now I'm compounding it 12 times and timesing by VO, which was 2,000. Okay, so I end up with 2280.57. Now, what you want is, that's what V12 is. If you were doing, if we were going to do simple interest now, so if I do simple interest, so I want V3 because it said if it was to be the same scenario. So remember the the nth term for simple interest is VO plus N times D. So in this case, N is 3. So I want it to be, so if I wrote out the formula, it would be 2,000 plus 3 times. Now, D, I don't know. So, but I can use the formula for D. And they're asking me, because they want to know what they want to know what the annual interest rate is. So that means little r is still the question. So instead of writing D, I'm putting the formula for D, which is R over 100 times VO. So if you look up your formulas, now we know what we want it to be. We want V3 to be exactly the same amount as we found for compound. And if I do that, I'm left with just one thing I don't know, which is what I need to know. And I'm just going to someone said it, just going to do solve, comma, R. So just so if you're not aware, this is the formula for D there. Yeah? So I found that. This is obviously VO and that was V3. So when you solve for that, you get R to equal 4.68%. And that's how I get that one.